All right. Good morning, good afternoon, good evening, wherever you are. This is a mic check. If somebody wants to just type in the chat there that they can hear me, I think we'll be ready to go. The chat should be open for anybody to write whatever they want. Awesome. Fantastic. Thank you, folks. Okay, so this presentation has been a long time in the making, in the sense that it is going to summarize quite a bunch of work that has been done over the years. So the idea here is to go over what is particular to using Android as a platform, and how you go about sort of managing that, or sort of doing anything about it, right? So it's a bit tongue-in-cheek, right? You know, the devil, the Android platform, and the details, but it's supposed to be sort of still kind of useful and constructive. Okay. So for those of you not familiar with my work, I wrote the embedded Linux book for O'Reilly in the early 2000s. I wrote the embedded Android book for O'Reilly about 10 some years ago. I'm most widely known in the Linux community for having written the Linux Trace Toolkit, which was one of the first tracing tools for Linux, and happy to report that other people are doing a much better job than I was maintaining tracing in general today. And you can still find my name here and there in the kernel until they discover what I wrote has been rotted and they take it away. Anyway, aside from these presentations, my sort of day job is to help people take Android and put it in all sorts of funky devices. And this has given me the opportunity to see a whole bunch of different use cases over the years. All right. Now, what I want to cover with you today is, the basic questions. Should we be using this? And if so, what does that actually mean? Of course, what is it that is required to get Android running? What does it imply to choose a platform to do so? What is the kind of software that you get from your vendors, the board support packages? What kind of boards you have to practice this stuff around? The large size of this, how do you manage that? And so on and so forth. All right, how to have an effective work setup as well. Okay, so it turns out that the original forbidden fruit was not an apple, which you can't license, by the way. It's an Android. All right, so this is the primary temptation. It's like, okay, should we not be using Android, and what does that actually mean for us on a practical basis? So what are the pros? What are the benefits of actually using Android in your device? Okay, first of all, it is very much the standard sort of user interface that most everybody is used to using. Be it another touch system or Android, they all sort of more or less feel like alike. The touchy, pinchy, zoomy thing is what users expect. People approach a terminal or anything like that, they expect to be able to sort of fiddle around and get stuff done. So from that perspective, using Android out of the gate sort of clears that for you. Okay, the user knows how to relate to this interface as a touch-based interface and get his or her stuff going. All right. Okay, it's open source, so you can take it. You can effectively do whatever you want with it, pretty much. Save for some license things that you have to understand here and there, but mostly, it's free of charge, sort of in the spirit of all open source things. The engineering behind it is fairly solid. We can, and I have had disagreements with the Android team about some choices they've made, but they're generally very solid in terms of what they do. They have very strong stories around the choices they make. And honestly, it is self-coherent, all right? Again, whether we like some of the things they've chosen to do or not is sort of, side point. At the end of the day, this is a very solid piece of software. It is based on Linux, so sort of, for me at least, it's sort of like runs within my bloodstream. It's like, okay, Linux, cool. You know, you already got that one on in my heart. So the fact that it's based on Linux also makes it very easy to actually get Linux stuff into Android, all right? Now, Android itself might be sort of, you know, allergic to some of these things, you know, sort of a body that rejects a graft of a foreign sort of heart or something, right? But generally speaking, you can get your way around and bring Linux stuff into Android. And of course, the fact that there's a tremendous amount of Linux stuff that's documented gives us quite some mileage with Android in terms of being able to actually understand and get things done properly. It does have a standardized API, and despite having, you know, worked in the embedded Linux field for a long time prior to Android and continued after Android, of course, it remains that if you choose something like embedded Linux, you are choosing your APIs, crafting them, teaching people about them, and you have to get people on board with those things. Hey, it's been done. Plenty of people still do it. It's you know, a perfectly reasonable thing to do. But it remains that one thing that Google has done with Android is they give us a standard API that everybody knows about, and that's just gold. All right, they curate this API. They are going to obsolete stuff, you know, in a coherent fashion, and there's a lot of documentation about this. So this is great. All right. And of course, what that brings with it is practically an unbeatable app developer ecosystem. This, by far, is one of the most compelling reasons to actually choose to use Android in your embedded system or customized device, what have you, because you can tap into tens of thousands, if not hundreds of thousands of developers that can actually write code for your system out of the gate. All right, they don't have to be taught about the particularities about specific things. You can choose to do so if you want to, but ultimately anybody that gets onto your device can start using it right away. And again, that cannot be discounted. A lot of people choose to actually use Android specifically for that reason, because they can tap into huge developer ecosystem. Of course, along with that comes huge app catalogs. There's a lot of applications out there that you can effectively choose from if you want to package them. We've even had cases where customers have told us, look, we're choosing Android because our hardware vendor has provided us with a sample application that runs on Android. So, you know, we want to use that. Okay, cool, right? So it becomes a very sort of easy to find something that fits the particular need that you're trying to sort of fill with Android, if you so choose to use it in your device. So there is, of course, you know, development targets for Android that are out there. So you can effectively, you know, choose to look at Pixel devices and such to start with and so on, instead of starting from scratch. But as I'll mention later, there are some caveats with that as well. And of course, it is a strong candidate for starting into any sort of AI or intelligent interface that you want to provide to users. Of course, we're all familiar today with the uptake with or interest in ChatGPT, generative AI, and assistants, and so on and so forth. It remains that Android is a very strong platform for tapping into assistants and all sorts of other things like that. And Google has been working, of course, over the years on a number of different sort of you know, additional functionalities on the edge, in other words, in the phones themselves or devices, for intelligent sort of intelligence AI or anything like that, neural networks and so on. So this is a very good thing as well with Android. Of course, it's also officially supported on a multiple number of different things. You know, handsets and tablets and TVs and cars and watches and what have you. They even had a foray at some point into the IoT sort of ecosystem, which they eventually, I think, sort of shut it down in as far as I can understand it. But anyway, there's a lot of things that Google sort of pushes Android into, and therefore are good fits if you are trying to use it. There are, however, some, of course, downsides with using Android, and that's where really sort of it bites, and you'll see I have quite a few of them. The first one is the learning curve. This is a tough thing to learn, okay? It takes a while to absorb everything about how to use it, of course, as a platform developer, customize it and that sort of thing. So be aware that if you choose to use Android, that's one area where you're going to spend a lot of time. And if that wasn't enough, the fact that it's sort of has a steep learning curve, its internals keep changing. So sometimes substantially, sometimes less so. My personal sense is that we're approaching a 20th anniversary of its life, I guess. If you assume that it was birthed in 2005, we're about 18 years into its lifetime, something like that. My sense is that things have sort of, in terms of internally, have stabilized to an extent. That doesn't mean there aren't interesting things happening in the internals, but there was a lot of rework that has been done at a number of different places over the years. The biggest, of course, is probably Project Trouble with Android 8, which was a major refactoring of how hardware support was done. And if you had done hardware support before, when you got after Trouble, it was a totally new world here. So those things have to be kept in mind, all right? If you study a given version of Android or you're familiar with one version, that doesn't mean that you necessarily won't encounter some surprises when the next version comes out. It is entirely possible that you do. So for example, between 4.1 and 4.2, even though those are ancient versions, just to give you an idea, they had dropped the BlueZ stack and went to a Broadcom-based stack for Bluetooth. And if BlueZ was the thing that you were familiar with, you were caught flat-footed with that one, and there's a lot of people that were actually very unhappy with that. And eventually, of course, they even morphed that further down, and they're moving on to a Rust-based, not REST-based, Rust-based Bluetooth implementation. So the internals keep changing over time. Keep that in mind. It is getting fairly specialized in terms of its internals and the complexity of some parts of the system. Every year, and since 2012, I've been helping organize the Android micro conference part of Linux Plumbers, which is a yearly Linux conference, bringing people in, working on the low level of the user space and sort of top level of the kernel, sort of hence the term plumbing there, to hash out some, pending issues or ongoing problems. And the idea there is to come in and talk about the things you're trying to solve and sort of bridge with the community, see how best to approach some of these problems. And even though I've been sort of helping organize the Android Micro Conference since 2012, oftentimes, I invite people, or we invite people to present things, and the material sort of is like, above my head. I'm happy that people in the room understand what they're talking about, right? The presenter and the kernel developers or whomever is in the Linux community can have their secret conversation there, their coded language. But ultimately, some of the stuff is very specialized, and it is not, impossible that you approach some things in the AOSP or the Android system, and you need to spend some time studying it and have a certain level of expertise in order to be able to know what to do with it. This one saddens me, but I have to say it. Unfortunately, I've been following this for more than a dozen years now. Android doesn't really have a comparative open source community, as you can see, for example, in the Linux world. All right. In the Linux world, you can go to the kernel mailing list, follow the debates about choices, and participate in those, or go look at the archives to see what happened, or even just look at the archives and figure out who was responsible for certain decisions, and maybe even touch base with those people. You won't necessarily have something similar to that with Android. All right. It's not that the names of the people responsible for different places are secret. Sometimes you actually go into the sources and you will see the names of sort of the owners of some subsections. But it remains that the overall ecosystem doesn't have the same sort of two-way street that you sort of have generally in open source projects. And I think that a good sort of a good example of this, or a good synthesization of this, the ideas behind that or underlying this, was made by Andy Rubin, who had originally founded Android at a conference several years ago when he was still steering Android, of course, where he said, open source for us is two things, the licensing and also the community side of things. And he said, we're very strong on the licensing side, not so much on the community side. So that's something to keep in mind. It is hard to find people that are qualified and understand this internals-wise. This is something that we have a lot of customers often coming to us and saying, "Hey, do you know somebody that's able to help us out here? We're looking for expertise in this and that area." And unfortunately, it's hard to come by. One thing, of course, that will come with Android if you choose to use it is a more costly BOM. All right, you do need, as I'll discuss later on, a high-end processor with probably GPU and quite a chunk of memory there to make it work properly. So there's a price tag for using Android, and that has to be sort of kept in mind. It is big, all right. It has a big footprint, and regardless of the actual metric that you use, and I'll get into some of that later on. Oftentimes, the devices that you buy on the market, so I've got here, for example, a Pixel phone. Well, the actual SoC on there is not a catalog part. You can't go to DigiKey, Mouser, Future, what have you, and order the chips that are on those devices. They're often sort of built to order. And usually you're going to have to buy large quantities before, or want to buy large quantities before you have a conversation with the silicon vendors. And oftentimes, with regards to Android, there's this culture of secrecy around it. All right, the NDAs that are in place, or the agreements that you have to get in place to get your hands on BSPs sometimes can be quite onerous. So, for example, if you've got yourself, if you're using a part from a vendor whose first letter will earn you a lot of points in Scrabble, you likely have an NDA that's very stringent about what you can do, and just to sort of have fun around with that. It might be something like, hey, if you talk, we'll go out, kill you, your family, your dog, and the neighbor just for precaution. All right. So it's kind of making fun of it a bit, but that. What it means, essentially, in reality, is that you're going to be in a situation where you can't really share and talk about what you're doing with other people. And that makes it complicated, because it is already a complicated system. If you want to go and get some help, the fact that you can't talk about it doesn't help you very much. The kind of corollary to this, the people that are using Android, the ecosystem around it tends to be very secretive about what it's doing. People don't share what they're doing, and they feel they can't talk for whatever reason, possibly because of course, actual legal paperwork. If you want to use some of the branding or the certification, then you will be effectively if you want to use some of the apps that users sort of recognize, then you're going to have to go through some certification. You're going to have to jump through a few hoops there before you're permitted to use that stuff. All right. Sort of, even though you actually can go and try to make contributions to Android through the Garrett system, you can submit patches, of course. It turns out that a lot of the contributions are made from Google in California, and unfortunately, it sort of like feels sometimes like they're, codes getting thrown over the wall, and sort of like we're just the peasants, sort of eating the food from the medieval peasants, eating the leftovers from the table of the people up there. Okay, and in terms of requirements for the build system, it is pretty onerous. Okay, it does require quite powerful systems, which you have to keep sort of updating over time, because the build system keeps taking more and more time to actually build stuff. The build system itself is quite peculiar. It is not your regular make with recursive sort of scripts being called and that sort of stuff. You have to get used to it and deal with the quirks that it has. So that's special. The BSPs that you get can be quite bizarre sometimes. I'll touch on some of the stuff a bit later on, but there's quite some material in BSPs that sometimes, at least for me, sounds counterintuitive. At least feels like the engineers working on it didn't really sort of totally understand the AOSP way and sort of just found something that worked for them. Sometimes, at least for me, I find that we don't have a lot of actual development boards to choose from. There are some, of course, and I'll mention a few, but definitely not sort of the same level as, say, the choice that you'll get if you try to go for using embedded Linux. There's a lot of stuff in embedded Linux. Okay, the OTA process or upgrade process is left as an exercise to the reader. The AOSP does have a bit of things in there, but the actual backends and the mechanisms and all that, that's for you to sort of more or less determine. Same thing with the in-field error reporting. And generally speaking, it is a system that is designed for very large quantities of devices, right? Not for small scale, which in the case of the work that we do with people in the embedded world, sometimes can pose a problem because, we're talking here about people that are going to sell hundreds of devices, thousands of devices, tens of thousands, maybe not millions certainly, like say a handset, right? Of course, if you've tried to put Android in an embedded system, one of the things that you'll see is that it does take quite a long time to boot. You can try to optimize a few things here and there, but ultimately there are a few critical steps in the beginning there that you won't be able to skip that are quite lengthy, all right? And people have tried all sorts of things over the years. It remains that this is a sore point, generally speaking, with Android. And I'm probably forgetting a few things, all right? So let's talk a little bit about what you need to actually get this thing running on your system. And the first question that you'll want to ask yourself is, are you talking about Android, trademark, in the sense that the full Android that a customer is expecting on their device, or just AOSP? A few years back, we had a customer that wanted us to help them get a fairly recent version of Android running on a beaglebone Black, and that's a fairly sort of constrained system. The processor's not very recent; it's kind of a bit old-fashioned now, and the memory's constrained, like 512 megs of RAM. And so when I was sort of first talked to a few folks I know in the Android team about this, they said, Android will never run on this. And I sort of wasn't able to make a lot of headway in this conversation until they understood that I was talking about AOSP. Like, oh, AOSP, that might actually work. Because essentially Android full is effectively, Android with the Google applications, right? If you're gonna want to get YouTube, Google, GMS and Play and whatever, that's demanding in terms of memory. So if you want to forfeit those, you can probably sort of go further down than what Android generally will go for. All right. Generally speaking, you're looking at something that's a 64-bit system with GPU, about 1 or 2 gigs of RAM, and about 16 gigs of flash. And if you take a look at, say, for example, Android Go, which is a sort of a trimmed-down version of Android for consumers, for devices that have less RAM, these are the numbers that are sort of published by Google officially, right? We're talking about say, 2 gigabytes for of storage for Android 13, right? So speaking of the system I was telling you about a moment ago, so the system there was a beaglebone Black. I was able to get to Android. We were able to get to Android 10 running on there, and the way we sort of got around the fact that there's no GPU is that we used Mini GBM, which is a software sort of render surface or graphic area, and Swift shader for the actual soft GL, since there's no GL, accelerated GL on that thing. All right. So generally speaking, the concept is if it runs Linux, you should be able to run Android on it, right? As I was saying earlier, in practice, you end up having to use high-end chips, often built to order. You're buying millions of chips from this or that vendor whose name is very well known and being used in handsets and so on and so forth. And yet, despite that, you do have more conventional options You have people running it on low-end processors and such, but generally speaking, Android's geared towards this. So you're fighting to bring it down to something else, right? So there are people that use it on x86, and RISC-V seems to be sort of an up-and-coming option for Android as well. So hey, maybe this opens up some cheaper selection of processors at some point in the future, TBD. All right, so the common sort of processors that you're going to be seeing, stuff from Qualcomm, MediaTek, Samsung, and whomever else that's out there, including custom ASICs. Right, there are some, for example, the Pixel devices have custom ASICs running on them or being used in them. So that's interesting. All right, the questions that you want to ask yourself when you're selecting a chip for your Android are primarily about, logistics of the chip. So can you buy small quantities of it? All right, can I go to DigiKey, Mouser, or whomever else and buy a few, or can I not? Right? If you can't, it becomes a bit problematic. What is the long-term availability of the part itself? Some vendors are not well geared to sell the same chip over a decade, and some other vendors are actually very well geared for that. And so it depends where you lie. Are you going to sell 3 million this year and you don't care if you sell any next year, or do you actually care about selling the same sort of device or PCB or whatever product that you've got there for the next couple of years? And in that case, how often can you resupply of that same processor? And of course, the other question is, how able are you to get support from the actual silicon vendor? I mean, silicon vendors are, of course, as any other business, concerned about the bottom line, and you have to understand how their business model works. Oftentimes, we've seen smaller players try to work with very large SoC vendors that sell, built to order, and there's impedance mismatch there. There's just not the right fit between those two sort of companies. So you have to go for something that fits whatever it is that you're trying to do as a product. The other thing is, what's the latest version that the silicon vendor supports, right? Do they have 13? Because this is the version that we're talking about today. Do they have 12? Do they have 11? And, whichever version they have, what is their historical track record of that vendor of actually making updates to the latest version of Android? That varies a lot. Sometimes they'll say, hey, we've got Android. Okay, cool. Which version is that? Oh, we got 9. Oh, that's awesome, but we're at 13, right? Whatever. I'm just throwing numbers out there, so not sort of pointing fingers at any specific vendor, but just saying, sometimes the Android checkbox may not be what you are looking for. Also, again, this is part of life, right? Different vendors are sort of usually used in different markets. So if you are trying to reach across cultural lines into a vendor that doesn't generally serve the market that you're in, maybe you're going to have some cultural barriers there. And then, of course, not to discount, how complex is it to use that part, right? Some of these BGAs have huge pin counts. Is that a 900 pin count chip? 250 pins? What's the complexity of the PCB that comes with that? So let's take a look now at the BSPs that you get for the silicon. All right. So we just talked about the actual vendors themselves. So they give you some sort of software, some version of Android that you're going to be using in your device. What is the actual flow of this from Google, so to speak, to you? So really the story starts effectively before Google, right? You've got the open source community contributing stuff, Google itself contributing stuff, the Garrett submissions, kernel.org, all this goes into the Android open source project. This is where you go to something like android.googlesource.com and you can sort of get the Android sources, the official Android sources. Now, if you're shipping a product, you're most likely not going to be going straight to that. You're going to get your actual Android from somebody else, all right? So what is that somebody else? Well, that probably is going to be some silicon vendor that gives you a BSP, maybe a community distribution. You've got a couple of those out there. Lineage OS being sort of like sort of a follow-up to CyanogenMod or whatever. So that's something, right? And sometimes, of course, you're going to be working with an actual board vendor that's providing you a ready-made board that runs Android, or possibly a design house that has taken a BSP and is designing something for you. And you're sort of like somewhere down there, right? And of course, the question is, what is the actual path from Google to you? What are the updates? Do you have access to that BSP that's being used by the design house to make its Android device for you, and so on and so forth, right? So some of the things that we've seen with the BSPs over the years, this is quite frequent, at least that's been my experience, that there are some custom build scripts, some custom things that are being done in those AOSPs or Android versions to make them build for the devices, which are not sort of part of the original thing. Sometimes it's innocuous, sometimes it's cringy. So just, be aware that this sort of stuff exists, including, of course, some image generation that's kind of like, I don't know what you're doing there, but that's not what I expect Android to actually do. But hey, it is what it is, right? You have to keep in mind that the engineers working on the BSPs are doing their best based on all the other things I mentioned to you, which are they themselves also are grappling with. Broken kernel configurations and build scripts. This one we've encountered a couple of times. So a long time ago, just to give you an example, I had this BSP from a silicon vendor that built a kernel that I couldn't use for f-tracing. All right, it's like, okay, wait a second. I want to do f-trace. This kernel by default doesn't do it. I have to go in and do a bit of brain surgery, reconfigure the kernel to actually disable a feature they enabled for security reasons in order to be able to do f-trace. In another circumstance, I had this BSP where the kernel that was built by the actual, if I used their binary image that came with the BSP, the kernel booted perfectly. But if I wanted to build my own, it would not. I would effectively get U-boot trying to boot the kernel, and then it would crash and keep rebooting. And after chasing this for a week, I discovered that they actually had a typo in a shell script they had for merging kernel configurations. Suffice it to say that I was not as sort of casual and calm and composed about it, but hey, it's just part of life, okay? These things do happen, okay? Sometimes, this one is kind of a bit funny to say, but it's real. I feel that sometimes the engineers are like, hey, we can do better than this, and then they cook up something else. It's almost always a bad choice, but hey, again, make do with what we got. One of the things that I don't like is when silicon vendors remove the default sort of targets that are in the AOSP put in there by Google. So for example, Pixel devices, for instance. And the reason I dislike that is one of the fact that we lack documentation and so on and so forth. It turns out that one of the references that you can use to see how things should be done is how Google's doing it. And that turns out to be looking at how they do it for the Pixel devices. So if you don't have those available in the source tree that you've got, you sort of have another tree that you have to go and get. It's like, okay, you're just wasting my time here. Leave it in there. It doesn't change anything for you. Sometimes, of course, functionality is stubbed just to get around limitations that the silicon vendor doesn't want to sort of deal with. It's less common these days, but still a possibility. Security is a very strong thing inside of Android, and unless you truly understand it, sometimes people will just shortcut around some of the issues, including, hey, I see Linux. Right, and of course, sometimes you actually have to have an NDA in place before you can even get your hands on the BSP itself, which is kind of a bit obnoxious. Okay, so one of the questions that we often get is, okay, do you have a board that you can recommend that we can use to actually do some Android development or Android testing? And these days, there isn't really a very strong, good answer for this. All right, we've used different things over the years to help people learn about Android. So one of the very first things we used to use is a beaglebone white, in fact, like the old ones. Panda boards and all sorts of other things over the years that we've tested. Unfortunately, what we've discovered is that oftentimes either the SoC gets dropped by the silicon vendor, hence you stop getting access to the actual board. The board goes out of stock, or Android is no longer supported on that chip, that sort of business. So you sort of continually have to move around. So the easiest thing to do these days is to get yourself Cuttlefish, which is the emulator. So in this case, for example, I've got Cuttlefish here running on one of my development machines, and you can see it just opens up in my browser. I can go ahead and sort of play around with this and start stuff, and go home and whatever. So for most of the stuff that is hardware independent, this will do the job, right? And even if you've got some hardware specific things, you can probably sort of stub it and have an application talking to that until you actually get to the real board. So it'll get you far enough. If you really want an actual device, the cheapest sort of entry point will probably be a broken Pixel device off of eBay. Get something with a broken screen, whatever, some quirk on it that makes it sort of not so cool. But hey, the Pixel devices are supported within the AOSP itself, so you can take a look at the current AOSP, go back, see how far in terms of Pixel devices their support, and grab something in there to your liking and use that as a starting point. Of course, you can buy a new Pixel device. That's totally legit, and most people that want to know about sort of what Google has done with the latest version of Android on an actual device, that's probably going to be a good starting point, right? Usually that's my go-to thing. I just dog food whatever they got there. Even if I'm a bit of a nostalgic person, I would have liked to have phones with keyboards. So all the phones on the market today aren't satisfactory, but hey, whatever. That's a side point. Okay, there are some reference boards supported inside AOSP, so you can go and get something like the Dragon Board 845 and so on. Some of these are supported by the fine folks at Lenaro, who are doing a great job at this stuff. So, have a look at what Google sort of lists on their website. Some people are running this on Raspberry Pis, and of course, any silicon vendor worth its salt is going to have a reference board or a sort of a device that they can give you, or board that you can use to actually start working on your product. So what does it take to port Android to your device? This is actually a slide from one of my classes about Android security internals, and I'm not going to sort of walk you through the entire detail of this, but generally speaking, there are a lot of parts to the boot system. So going from effectively crypto keys for signatures, secondary bootloaders, actual bootloaders, trusted execution environments, the actual kernel that boots, and effectively the images that get sort of booted ultimately by there. And once you get to the actual sort of starting of Android itself, it's a completely whole world of its own. After the kernel boots, you've got these native daemons that start with the Zygote being a primary one. Then tailing in with system services, and after the system services started, you then get the user interface that actual users are accustomed to seeing. So, of course, what are the steps? Generally speaking, of course, you want to get your bootloader and whatever, ARM trusted firmware stuff kind of going, okay? You get into the kernel, and this is where the fun starts. So you usually want to start from what the kernel that the silicon vendor has for you, and tweak that to your liking or to your needs, whatever those are. Reconfigure the kernel, of course, for whatever needs that you've got that aren't there by default. Have a bit of fun with the device trees. Those of you who've played around with that can relate. So you have to tweak the device trees to match your specific board. Of course, you start with the device tree that's in the default board, and you tweak it to your liking. And of course, you want to get to a serial console. That's really like the first thing that you want to get going. So you can actually start shelling in there or seeing messages from the kernel as it's booting. Generally, you want to build the AOSP in a -eng build, the dash engineering. If nothing else, when you sort of ADB shell, it'll give you a root shell sort of immediately. Now, once the kernel has booted and has passed boot time and is starting the init process, the first two things that you might actually stumble on is Zygote not starting and Surface Flinger not starting. Zygote generally comes up okay, unless you've got too little RAM. If you got too little RAM, then you're going to have to start sort of playing around with the parameters that are used to configure Zygote to make sure it fits in that amount of RAM. This is something that, for example, in the case of the beaglebone I mentioned earlier, the beaglebone, I had to tweak the RAM for Zygote for it to actually start. Eng is the same as UseDebug. So just picking up the question here from the chat. So Eng is not the same as UseDebug in this, if nothing else, in the sense that if you do an ADB shell in Eng, you're immediately root, whereas if you do an ADB shell with UseDebug, you end up with a $sign shell, which means you're a shell user, but then you can become root. I find that tedious, just like, okay, get out of my way. I want ADB shell and get my root right away. And there are a few sort of things that are going to get built with -eng that are not going to be in a user debug build. That being said, a lot of these silicon vendors, sort of, if you follow the recipes, they have you build user debug. I find that totally useless. I just remove their user debug and put a -eng and go with that. At least that's my approach. So generally, Zygote is not something that's going to be sort of too much of a problem to get going, again, unless you've got too limited RAM. The one that sort of ends up being the first thing people stumble on is going to be Surface Flinger. So Surface Flinger is the graphic sort of party, the sort of equivalent to X window, if you want, in Unix. The biggest problem, of course, is if you don't have a GPU, then it's sort of like, wait a second, how's that going to boot? So the shortcut that we used in the case of the beaglebone, and in the case of other boards as well that don't have any graphics, is to use a sort of replacements or fake versions like Mini GBM and Swift Shader, which actually, by the way, is what's being used by Cuttlefish itself. That's the emulator that you saw there. This is frequent, so the failure of Surface Flinger is frequent. So of course, presumably, if you got a legit chip with the GPU, the silicon vendor has the binary blobs and whatever else that you need to get this going. Okay, so you've got the kernel booting, you've got AOSP booting, awesome, you're ready to start working. And this is where sort of the learning curve starts to bite in, all right? If it hasn't been in before. So I came to Android around 2010-ish from an embedded Linux background, and my simplistic view is, hey, it's based on Linux, this is going to be a walk in the park. And it turned out not to be so much, all right? It took me about half a year to a year to sort of start to get my bearings. I eventually wrote a book about this, and I've been doing this for a good dozen years now. Now, the original version that I started learning on was say around 2.3-ish. So you got 4 gigabytes of sources, and when you built that, you got yourself a 10 gigabyte tree. These days, if you get 13, you got 70 gigs of sources, and it builds into this whopping 260 gigabyte directory. All right, it has exploded, all right, in terms of size. So this is a huge piece of software, all right, that you're dealing with, no matter what sort of a metric that you use to size it up. Okay, so just bear in mind that there just isn't any single human being on this planet that fully understands Android. This person doesn't exist. If they do, please contact me. I'd love to meet you. There are, of course, people within Mountain View that have very good understanding of how Android works overall and their specific area of specialty, but with the Android team, or Android teams, because there are many, have very specialized know-how, and it's happened at several occasions where I asked a person that I knew, hey, how does this work? He's like, yep, sorry, not my territory, go talk to this person. And that's perfectly legitimate. I mean, the thing is big, right? And it's hard to understand. So personally, despite working on this for a long time, I'm still learning stuff as I go, and sometimes I get surprised by people I talk to in classes or elsewhere. It's like, hey, did you know this? It's like, oh no, I did not. That's so cool. Thank you. Right? So keep in mind that it's tough. All right. There just isn't going to be any silver bullet around that one. If you want a reference, my go-to reference happens to be source.android.com. It's the best you'll get to an internals book. It's not, necessarily up to the minute, detail of how things work. But generally speaking, the Android team tries to put stuff up there that is as up-to-date as they can. But of course, you have to keep in mind that, as any development team, their priority is to deliver product, not write documentation. So The documentation is definitely something they have been working on over the years, on a fairly consistent rate from at least my perspective. So, kudos to them. But it is still possible that you go to source.nro.com and the document that you're looking at is, 1 or 2 versions old, and that's okay, right? It's up to you to sort of grasp that and then sort of move on and try to understand what's afterwards, right? And of course, if you can find people that know, then hey, that's great as well. So what does it take to actually have an effective development setup? So if you go on Google's source.nro.com and you look up the initial references or recommendations they have, this is from the site. And this is 2 years old, of course, almost 2 years old. As of June 2021, Google is using 32 core machines with 64 gigs of RAM, which take about 40 minutes for a full build, all right? If you don't have that sort of level of, machine, assume that it's going to take you a lot more time. So several hours of build is not infrequent if you're building it from scratch. So that's something to be kept in mind. And here is just a bit of a personal experience rundown from what I have seen, okay? So Gingerbread, which is as I told you, one of the first versions I cut my teeth into quite heavily, took me about 20 minutes to build around 2013. Now before COVID, my sort of hardware choice or build system choice had to be a laptop because I traveled around a lot to go visit customers and such. And so I had to have a machine that was able to, build the full thing. Now the laptop I had around 8.x would take about 4 hours to build that. And when 9 came out, it took about 10, 12 hours. And at that point, it's like, okay, that's not going to be very useful anymore. I need something else, which is, then I got the machine that I'm actually using to make this presentation, which is a 6-core Xeon. And that brought my build downs down to 2 hours. 10 came out, 3 hours and some. 11 came out, was 4 hours and a half. And of course, with COVID, it was like, okay, shut down, there's no travel anymore. Maybe I can get myself a fixed build system, right? And so my current statistics for 12 is an hour, 13 is 2 hours on the same laptop that took us some hours earlier I told you about. It takes about 5 hours and a half to build 13. So my current build system is a fixed AMD based system with 128 gigs of RAM, and I use essentially KVM. This is a sort of cooked up thing I came up with that it suits my needs because I want to be able to get AOSPs from all over the place and not mind the security or integrity of my actual development system. So I care about security and I don't want to just sort of grab anything on the internet and just compile it on my machine and sort of like forget where it came from. So what I've got is effectively just a PCI card, a USB PCI card that I hand off to a KVM instance, and I can plug in onto that USB card a whole bunch of SSDs, USB SSDs with various AOSPs. And of course, the AOSPs are so huge that, I can just swap these things around. It's like, okay, this one's got this AOSP, this one's got this other AOSP, and, whatever. I can just sort of hot swap my actual AOSPs, and they're all sort of KVM'd, so away a bit from my sort of machine. And sort of like just a really big picture of it here, I'm using this PCI card in pass-through mode to actually hand it off to the KVM. For what it's worth, this was a struggle a bit to figure out because it turns out that pass-through KVM is hit or miss. So I actually had bought 2 cards, 2 USB PCI cards. One of them seemed to work until it didn't. Sort of, at some point when I was just downloading AOSP, the whole thing would crash. The whole system would crash. The actual workstation itself, the build system. So it's like, okay, wait a second, this is wrong. There's some hardware issue here. The second one worked as a term, and like having spent a lot of time on this on the internet, trying to figure out, hey, what's the experience of other people? It turns out it's hit or miss. So depending on the development box that you've got, it may or may not work for you. Some cards may work, some other cards work. Hey, have fun. So okay, there's no standard here. We've seen all sorts of things, including cloud sort of machines. If that works for you, cool, have fun with that. But you do want to find a system that is very powerful because it is a very demanding sort of piece of software to build. It requires a lot of RAM, a lot of storage, so don't go cheap on that. You'll pay it in salary or time. It's just, there's no way around it, right? Now, remember, at the end of the day, that the folks in Mountain View are not sparing any pennies to get their developers the best hardware out there. So it's entirely possible and very likely that the Android developers do not feel your pain. So this is not a problem to be solved other than buying more powerful hardware. So anyway, you're chasing down that one as well. Okay, so let's say you've got yourself a system built, you've got your thing running, it's shipped. Cool. What next? All right. What is it that I have to keep in mind after I have shipped my my system? So, of course, the questions are, how long will Google support this AOSP? I think I was peeking at this, a few weeks back, and I saw in their at least security bulletins, stuff back to version 10. So that's, it depends, right? I don't know that there's an official statement on the number of versions they support. I'd love to see one if there is. Maybe there is, I haven't seen it. Again, too much information, I can't know it all. So if you do know that answer, I'd love to hear it. But generally speaking, you can look at the security bulletins as sort of an indication of how far back they support their stuff. So that's cool, but then, okay, how long will the silicon vendor support the version they gave me? That's another question that's sort of interesting to ask, because that also will vary. They're struggling with the same things that you're struggling with. This thing is really hard to follow, it's hard to understand, and so on and so forth. Okay, the kernel support as well, to be factored in. And then, okay, so what about the upgrades, right? There are some companies out there that specialize in this. You can sort of Google this around. There are a few of them that sort of specialize in helping people get their Androids up to date, provide a backend, mechanisms, even, the whole tie-in to make it work, including also runtime device monitoring and whatever else that has to be done around those devices. There are several proprietary offerings out there, and even sometimes open source ones that might fit the bill. But those are things you have to sort of engineer for from the get-go. Right. So a few sort of closing thoughts on this all, on everything I just mentioned here in the past hour or so. So of course, if I'm doing this and I spend time doing it, is because I like it and I think it's a value to customers. We've seen people do fantastic things with Android. So I love this system. I think it's great. I think it's amazing that Google's giving this away. But that doesn't mean that there aren't, the devil's not in the details. And there are many devils in those details, as this presentation hopefully has made clear. So what we try to do is share the work that we do in as much as possible. So you can find our class material in Creative Commons licensed on our website. There's slides from this presentation, other presentations that we've done elsewhere over the years. Even though we've not updated SlideShare in a while, there's a whole ton of slides from past years on SlideShare that we had put there. And from time to time, we try to make videos like this one to share some of the experiences that we have and things that we see. So yeah, that's pretty much it really for on my end. Hopefully this has been useful to you. And if you see this in the future and you sort of, find that something I said was incomplete or maybe even wrong, please feel free to leave a message in the comments. I'll be happy to pick that up and respond back. And maybe just open it up for questions in the chat if there are any. Wait a minute or two here, see if people have some questions, and otherwise that'll be that for me. All right. Good. So it doesn't seem that we've got any pending questions here. Thank you all for attending, either now or in the future. And if you've got anything you want to add, please feel free to do so in the comments, and we'll pick that up when we can. Thank you very much. Take care.